Assalamualaikum. Grup kami akan membentangkan berkenaan dengan solar panel. Itu subjek BMM1523 Engineering Material. Dan saya Muhammad Farid bin Zainuddin.
Saya Muhammad Aidam bin Jafar. Saya Farham bin Yazlak.
Saya Muhammad Zainal Fazlan bin Ahmad.
Untuk material used to make solar panel. Solar panel is a module which is a combination between solar cell. Solar cell is an electrical device that converts the energy of the light directly into electricity. Solar cell is made from semiconductor material. From this part, the semiconductor has an electrical conductivity between the conductor and insulator, silicon. First generation solar cell for the history is a wafer-based cell made out of crystalline silicon. Commercially predominant PV technology that included materials such as polycrystalline and monocrystalline silicon. Polycrystalline silicon produced by Siemens process. This process involved distillation of volatile silicon compound and their decomposition into silicon at high temperature. Monocrystalline silicon is produced by Swarovski process, melting high purity. Semiconductor grade silicon and the use of a seed to initiate the formation of the continuous single crystal. Performed in atmosphere, such as argon, and in an inert crucible such as quartz. This is part of the solar cell PV polycell, generally less expensive and have a bluish hue to them, mono and poly.
Next, second generation solar cell. Commercially significant in utility scale photovoltaic power station, buildings integrated photovoltaic or in a small standalone power system. Made out of thin film solar cell that include amorphous silicon, CDGE and CIGS cell. Amorphous silicon is the non-crystalline form of silicon. CDGE, which is cadmium telluride PV, consists of a simple and polarization structure containing a p-dot CDGE layer matched with an A and dot cadmium sulfide CDS layer. CIGS imposing a thin layer of copper, indium, gallium and selenium on a glass or plastic backing, along with electrodes on front and back to collect current. This second generation solar. Okay. For third generation solar cell, it includes a number of thin filament technologies, often described as emerging photovoltaics. Most of them have not yet been commercially applied and are still in the research or development phase. Many use organic materials, often polymetallic compounds, as well as inorganic substances.
Okay, new solar power material organic. First is carbon. Carbon material have several traits that make them appealing to energy developers. There's no fear of running out of carbon. These materials, since they are nanomaterial, they are solution processable. They can be deposited by spraying and coating without high temperature or vacuum. This exotic carbon structure can come from renewable sources. Carbon-based solar cell could also be more stable than silicon or polymer-based solar cell, which can wear out then exposed to the elements. For the second based on polymer and nanoparticle can be used for many applications, small gadget, power plant, energy production. Very cheap, made of environmentally harmless material, thin, light, highly flexible. As environmental advantage, more energy efficiency.
So the conclusion for the solar cell, nowadays photovoltaic cells are mass produced by many OEM. One of the main focus on many solar architecture is efficiency. How much of the sunlight that falls on every square meter of the solar panel can be converted into electricity. Solar technology is very important as it is the future. The energy, since every resource are the scarcity and will be inevitably gone from the earth.
So the main function of a solar panel is to convert energy from sunlight into electrical energy. So these black squares are the actual solar cells. The electrical connections are kind of slapped on top. Light travels in the form of what are called photons. Photons travel right from the sun, and as soon as they strike the electrons of a silicon, that electron, now that it's energized, it's actually going to travel from the p-type silicon to the n-type, and this is what is creating your current. And so then what the solar panel does is it pushes that electron through a voltage, the product of voltage and current.
Hong Kong has millions of electronic devices, such as remote controllers, clocks, and laser pointers. All of these devices are powered by batteries, which are toxic. So we like to replace these electronic devices, the batteries, with solar cells. So for example, this is a laser pointer driven by solar cell, powered by solar cell, will save Hong Kong a lot of money and also save the environment of Hong Kong. Conventional inorganic solar cells are very complicated to produce, and they're very expensive. As a result, the contribution from solar cell to global energy demand is only about 0.1%. It's very small. So we need a new solar cell technology that is easier to produce, that is cheaper. So we developed a new generation of organic solar cell materials that have a very unique temperature-dependent aggregation property, which enables several important features for our solar cells. First of all, our solar cells are more efficient. Number two, our solar cells can make thick film devices, which makes roll-to-roll printing. You know that newspaper printing is one of the fastest, cheapest, and most efficient production methods, just like the printing of newspapers. Number three, our materials can control organic solar cell morphology very well. As a result, we can use cheaper materials. We can reduce the cost